continuing our discussion on this Ethernet or CSMA CD, which is actually generally applied for coaxial cable. So, that is something we will be further discussing today. So, what we have already started discussing about is that okay. So, for CSMA CD or for Ethernet, so let us say we have the Ethernet cable and let us take the two distant node. So, we are talking about over here Ethernet bus of course. So, to distant node where the systems are connected. Now, we have already demonstrated what is the time required for detecting a collision or detecting the presence of a particular node transmitting, that is something we have seen. So, we have already told that it is dependent on the span of the network. So, which is the we have talked about SD as a span of the network, that is the distance between two farthest node. And now, if the velocity of electromagnetic wave which is propagating through this coaxial cable is c, then it is SD by c, that is the time it takes for this signal whenever he is transmitting the first bit of it to reach this particular location from his transmitter to his receiver. That is something we have already discussed. And after that, after this SD by C, we have also talked about some amount of detection time, because we have to actually integrate. Detection is all about integrating. So, few bits we have to take, we have to integrate and then try to see whether it is beyond some threshold power level. Okay. So, that is the overall time to time taken to detect presence of a signal. Okay. Now, what about collision? So, if I am transmitting, I need to know whether others are transmitting or not. Okay. Now, for collision we have also talked about this vulnerable period, that means the period over which others cannot detect my presence, can start transmitting and then I detect the collision. So, this might happen, and that is due to this separation or distant location of two nodes. Okay, and there is a finite propagation delay between them. So, because of that there is a vulnerability period where somebody might start transmitting. Even when he is transmitting, he knows that channel is free, still what might happen, others without knowing the presence, even though they are doing carrier sensing, without knowing the presence of this particular node, they might start transmitting. And then there will be some amount of time that we have calculated that will be taken for detecting this collision. So, let us try to again one more time try to see what is that time. So, SDC plus TD, that is the time this receiver after this has started transmitting. So, let us say in time frame for this is let us say node 1. So, for 1 transmitter started transmitting the first bit, this is for node 2, let us say this is node 2. So, his receiver after some amount of time, which is actually we are talking about this SD by C. So, that amount of time he will receive the first bit and then he will keep on receiving, but he also requires some TD amount of time which is required for his detection. So, at this point he can only detect that there is a presence of some other node and he will abort transmission. But what will happen, the point, let us say this is t, from that time instance this particular amount of time is still vulnerable for this node 2, because for node 2 he still does not know the presence of, he only knows the presence of that node at t dash. So, this amount of time SD by C plus TD, that is the time which is the vulnerable period where he can still transmitting. So, node 1 can start his transmission. So, anywhere over here he can start initiating the transmission. So, from here or from here he can start transmitting. If he transmit, now let us see it from the perspective of node 1. So, let us say at the last moment of vulnerable period he start transmitting. Then how much time it will take to reach over here? It will take another SD amount of time, SD by C, and then he will be receiving the first bit. Again for detection he requires TD amount of time. Okay. So, this will be possible. So, let us try to see what is the overall time that for node 1 to detect a collision, even though he was the only one, he has seen the channel free, he was the only one who was transmitting. So, even then there might be collision because of this vulnerability period, because of this propagation delay and finite distance between some two distant node. Okay. So, that will be overall SD by C plus TD into 2, that is the overall vulnerability period. This is something which is a very important parameter, you will see later on. So, this is the amount of time which will be required for detecting, if there is a collision, for detecting a collision. Now, the thing is that if within this time my transmission is over, then I will not be able to detect the collision, as you can see. See what has happened, if this packet is this small, like I have given in this example. So, at this particular instant, his transmission which will be coming back from himself, he will not be able to detect that, okay, which is just coming back from this one, that will take very small amount of time, because the propagation delay is very small from his node to the tap and back. Okay. So, he will be receiving his own packet after some amount of time. If this packet is over by the time he receives the other guy's packet, okay, then I will not be able to detect the collision, or I can say there is no collision actually as such. There might be collision if it is targeted for some other node. Okay. For this node there might be a collision. Always we have talked about collision is a phenomena happening at the receiver. So, it might be, suppose he is targeting this one for this guy, for him it might be a collision, but the one who is initiating the transmission, he will not be able to detect the collision. So, that is a danger which is already there, that I might not, while transmitting, I transmit my packet, I take some amount of time to transmit the packet, but for detecting a collision it takes huge amount of time, this at least this amount of time that is required for detecting a collision in the worst case scenario. If the other node who is transmitting, he is at the furthest location from me, and then detecting collision might take in the worst case this much amount of time, and within this amount of time is my packet is already over, the transmission time of the packet, this is where we are talking about the transmission time. Okay. So, that is this time. So, if the transmission time is over, then I will not be able to detect collision, because my packet is over. So, somebody else's packet I will be receiving and I will not detect a collision at that point. So, therefore, the packet size, this is very important, packet size must be greater than to create, to means avoid any kind of confusion that will be happening in the network. Because if this is not true, what might happen, I can still create a collision at the receiver. Let us say this node is exactly at the middle point between these two. So, there might be a collision, chance of collision over here, which will be created by the transmission of this guy and this guy simultaneously. Whereas, because my packet size is smaller than this propagation delay, or twice the propagation delay plus detection delay of this farthest node, I will not be able to detect that collision, but it is happening at the receiver. So, that is a very dangerous situation. I should be able to detect collision, because collision detection is one of the inherent feature of this particular protocol. So, therefore, I have to carefully design it. What is the careful designing? It is very simple, just by putting this condition. I take the farthest node, that is SD, that is the worst case scenario to detect a collision. So, I calculate that and I create my packet more than that packet size. Okay. So, packet size means with the transmission rate, it will be amount of time that the packet will be occupying the channel, okay, for its transmission, or that can be talked about transmission delay, the first bit to last bit, what is the time taken to transmit. So, if my packet size is bigger than that, I will be sure that whatever happens, whichever node tries to transmit, I will always be able to detect a collision. And once I detect a collision, then I can abort transmission. Okay. That is where I save actually the channel. Okay. So, that way what I will be ensuring, if you see this carefully, so what I am trying to ensure, again we had that slotted system. We have also talked about few of the slot, after I do stabilized aloha and all those things, few of the slots will be free, few of the slots will be busy, where successful transmission is going on. So, idle, successful, and few of the slots there will be collision. We have also seen the probability of them, Okay. So, that is something we have already seen. So, what will be the probability of these things, that also we have calculated. So, we have seen idle and success almost occupies same amount of period, 36.8%, and collision takes little bit lesser amount of this one. Okay. But there is a catch. What we wanted to do, we have seen that if we do that, only 30 at max 36.8% of utilization I can get if all these slots are identical. But we have also said that maybe we will now try to reduce this slot size, keeping the probability same. We will try to reduce this slot size and this slot size. So, what was the assumption? That this slot size can be reduced by doing this CSMA or carrier sensing. So, what do I do? Whenever I sense that somebody is transmitting, I immediately declare that that is the end of the idle slot, and I can go to next slot. Okay. So, this is something I can always do, until somebody is, if I detect somebody is transmitting, then I can actually skip that entire transmission time. I will be keep on sensing the channel, I will still see he is transmitting. So, I will keep on avoiding his, when he is transmitting I will never collide, because I am doing carrier sensing all the time because of this detector. Okay. So, idle time is eventually what is happening, just the detection time. If that detection time, whatever the TD is, if that is small enough compared to the packet size, that is exactly what we are ensuring over here. As you can see, everything is falling in place. So, we are also means proposing that the packet size, or this packet size means it is in terms of time. Okay. So, time it occupy, the time it occupies the whole channel. If that I am keeping much bigger than, generally I will be trying to keep it much bigger than this one, then my success time is much bigger, whereas this detection time is much smaller. So, that will be my idle time, just detection time or little bit extra than detection time. So, because I know that at least that much time is required to sense the channel is free or not. So, that is the definition of idle time. So, I will be at least keeping that much for idle time. So, every time what will happen, I wake up. Okay. So, maybe a successful transmission has happened, then I will actually compute this means TD amount of time, I will detect whether the channel is busy or not. If I see it is not busy, then I can immediately start transmitting. Okay. So, if I take my success something like this, that it is the packet transmission time followed by a detection time, then immediately followed by that, what will happen? That will be a idle time, that will be again equivalent to a TD or just little bit bigger than TD. If I do that, then the next node also will be able to detect. If nobody transmits over here at that point after detecting, that means channel is idle. So, it will remain idle for just TD amount of time, and then again another node can detect if he has something to transmit. If something comes over here, he will be able to transmit, capture the channel. So, the idle time eventually becomes much smaller, and this condition also provides that. But remember, due to this particular thing, there is a minimum size of the packet that is determined. Okay. So, that is something in Ethernet we have to see, that there is a size which is the minimum size of the packet, that must be greater than this. That depends on span of the network and the detection time, these two things if we know. So, let us say span of the network is depending on how much, how farther I can put my LAN, up to what distance, what will be the farthest distance between two nodes. If I take that as 500 meter, accordingly I know this parameter C and I know this TD parameter, I will be able to calculate what is the minimal packet size. Okay. So, these are the things I will be always able to calculate, that is what people have done already. So, it's okay. So, that is why probably you will see this packet size will have a minimum packet size always specified, that should be happening. This is one thing, and through that you can also see that protocol design is coming in place. Whatever we have understood from queuing theory or analyzing the stabilized slotted aloha, whatever we have understood, that is very nicely taken into account by the help of this CSMA. So, I could reduce the idle time by a huge factor. So, that will be depending on this TD to packet size in terms of time. By this factor I will be able to reduce. So, if I call this as beta, so with a beta factor I will be able to reduce my wastage due to idle period. That will eventually increase my overall throughput. So, that will be always happening. So, basically I am now penetrating the throughput in this idle time, that 36.8% idle time was there, I can penetrate into that. As I reduce my beta more and more, so that I can increase the packet size more and more, I will be able to actually penetrate inside this idle time. That means I can make this idle time small and small, his percentage will be reduced and the successful percentage will be increased. The next thing that we should target is this collision part. Okay. So, now let us, from the light of the previous discussion, let us try to understand how can we reduce the collision time. So, let us say we have talked about collision detection time. What was the collision detection time? We have already seen that, that is 2 into SD by C plus TD. So, that was kind of collision detection time, worst case collision detection time. Okay. So, basically this worst case collision detection time, if I take, after detecting a collision, immediately a node can abort transmission. So, what will be the overall amount of time? So, let us try to see what might happen if you take this example of collision. Let us say the packet is quite big, okay, it goes beyond this vulnerable period, SD 2 into SD by C plus TD. If that is the case, one guy will be able to detect the collision, that is the first guy, but for second guy, he has started transmitting, he might take some time or the other guy might take some amount of time. So, we can try to see what is the worst case collision detection time for all the station. Let us try to understand for this guy, what is the collision detection time, when he will be able to detect the collision. As you can see, he will be able to detect the collision immediately. So, after he start transmitting, he immediately sees that the other transmission is coming in, another TD he will be able to detect collision. So, he detects collision much earlier, as you can see. So, basically what you can see, all other intermediate nodes, their detection of collision will be at least much lesser than this amount of time that the first node is getting. So, that is the worst case scenario, that you initiate transmission, you are probably the furthest node and you are getting collision with the other end node, which is situated at the highest distance in the network possible. So, for that node 1 which we are talking about, for him we can now understand that that is the highest time he will take to detect collision, all other nodes will be detecting collision earlier. If that is the case, this is the worst case collision detection time. Immediately what I can say, that if this is the worst case collision detection time, so for that node who is detecting collision at an earlier stage, they can actually start issuing a jamming signal just to facilitate the collision time. So, what is happening, as you can see over here, what we have observed, that some of the nodes, see this node is starting to transmit, some of the nodes might detect collision at an earlier stage. So, talk about all receiver, everywhere they are placed. So, who is now, let us try to understand in the worst case scenario, who will be the first one to detect collision? That will be the furthest node. He will detect collision at the first instant at time SD by C plus TD. After this time only he will be able to, probably he has to add another TD because he has to detect collision also. So, after this much amount of time he will be able to detect collision. So, as we can see, that is the, in the worst case scenario, that will be the maximum time to detect collision. Once somebody detects collision, immediately he can start transmitting a jamming signal, that he can do. What is the purpose of that? Jamming signal means it is a high power signal, more powerful than any other transmission. Okay. So, if we transmit the jamming signal, what will happen? Now, let us try to again delineate this particular thing diagrammatically. So, let us say I have node 1 and node 2, they are the farthest. Okay. 1 and 2, the distance between them is SD, time travel to from one node to another node is SD by C. So, let us say he start transmitting at this instant t. So, basically node 2 will be detecting it after SD amount of time. So, this should be SD by C amount of time. So, node 2 start detecting it. Okay. Now, after that he will take TD amount of time to detect his presence. Before that, if he transmit, he will still be able to transmit it. Okay. Now, if he start transmitting, if this transmission is still going on, then he will be able to detect collision after another TD amount of time. He will be the first one, okay, to detect this transmission in this worst case scenario, if two nodes are at the distant and they are transmitting simultaneously. So, he will be the first one. All other intermediate nodes, after some amount of time, when this both these things comes over here, then only they will start detecting. So, they will be detecting at a later stage, and the last one to be detected collision is this guy, and that time is 2 into SD by C plus TD, that is something we have already discussed. So, for him it is actually SD by C plus TD plus another TD. Okay. So, that will be the amount of time this guy will be. Generally TD is very small compared to even SD by C, also TD will be small. So, we can take that this is where the first means that second guy will be able to detect a collision. So, once he detects a collision, it is his responsibility just to tell everybody else that there has been a collision, so that they will be taking much higher amount of time. So, just to avoid that, he might start sending a jamming signal. Now, if he starts sending a jamming signal, what you can see that jamming signal, when it will be received by the other guy. So, that reception of the jamming signal will be again with a propagation delay. Okay. So, whatever happens, as you can see, this collision detection added with a jamming signal, this will always take this 2 into SD by C plus TD, this much amount of time will be required, plus there might be a jamming signal transmitted, whatever that time is required. So, this amount of time is the collision time. After the jamming signal has been transmitted, everybody will abort transmission immediately. They will detect, okay, there is a collision going on, till the jamming signal is gone, they will align themselves up to, they will be keep on listening up to jamming signal end, they will align themselves. Whenever that jamming signal goes, again they will start creating their slot. So, the collision ends over here after the jamming signal, very high transmission. So, in between there was some collision probably. So, two were transmitting together. Okay. After that, this jamming signal has been transmitted. So, after this, then again everybody will wait for TD and then will attempt, depending on the kind of protocol we have described already in means our this slotted aloha or stabilized slotted aloha. So, basically all backlog nodes will try with some probability, all this new nodes, whatever they have received over here, whatever transmission they have received, that they can with some probability they can try those things. So, they can do that, and then idle slot will follow, or successful, if somebody captures the channel, then again successful slot will follow. But now, whatever this time, if this is again less than the packet size which we have already told, then the success will be again having a higher this one compared to the collision one. So, again we get an advantage. So, the collision time will be percentage of time will percentage of their observation will be same, but their time has been reduced. So, overall percentage of occupancy will be reduced and your throughput gets increased. So, this is the technique they have employed with collision detection and carrier sensing to enhance the throughput. Okay. So, what we will now try to do from there, two observation or two very important criteria you have seen. One is that by carefully understanding the timing diagram, we could come up with the packet size, what is the lower limit of that packet size. From there, we could also understand what will be the collision duration and what will be the ideal duration, and how they means how by increasing packet size we can actually reduce these things or reduce the effect of these things, which are the detrimental effect, because they were reducing our throughput and we wanted to enhance the throughput. So, that after we have understood these two things, what we can now do, we can see its wireless counterpart, what happens over there. Okay. So, that will be our next target. In the next class, we will be starting to discuss about what happens in wireless media, common wireless media, not a coaxial media, not the wired media that we have been talking about. So, we will try to see that next class. Thank you.